Leaf chlorophyll content is a very good indicator of nutrient deficit, for instance nitrogen. There are techniques to measure leaf chlorophyll content based on the chemical extraction of chlorophyll and subsequent measurement of absorbance with spectrometry. But in this practicum I will show you a non-destructive way to assess the chlorophyll content of a leaf using the CCM-200, which stands for chlorophyll content meter, and the model 200. It is a portable spectrophotometry device that clamps the leaf lamina, shoots a saturating pulse of light and measures the absorbance of the leaf. It measures the optical absorbance at two different wavelengths. 653 nanometers, that corresponds to chlorophyll, and 931 nanometers, that is in the near infrared. The 653 nanometers fall in between a peak of chlorophyll A and B. The 931 nanometer serves to compensate for mechanical differences such as tissue thickness. The units given by the instrument are CCI, chlorophyll content index, and it is calculated as the percentage of transmittance at 931, the near infrared, divided by the percentage of transmittance at 653 nanometers. The chlorophyll content index can be transformed into chlorophyll content by a calibration curve that can be found in papers, or that can be built by also doing chlorophyll extractions and measuring chlorophyll content in the laboratory. But the CCI units are also of common use and can be directly compared to other studies that use it. The other instrument that you will see in this practicum is this Dual X, and it exists another one famous called SPAD. All three, CCM, Dual X and SPAD, they use a slightly different approach to assess chlorophyll content by using different wavelengths, etc. So an intercalibration is needed to compare the measurements of all the instruments. And in this practicum, Dual X and CCM-200. In this practicum, we were asking you to search for leaves of different chlorophyll content and measure them with the CCM-200 and the Dual X. The operation is very simple. It's here, then we have a button to start it up. Then we run it. It asks us here, simple option, measure, and then now it tells us to hold the arm down to calibrate. Calibration is on, and then now we append, in appendix we make measurements. It's very easy to use. For instance, this leaf can be just put inside, hold for 2 seconds, and then we get a value 17.3. More in this part will be yellower, then we have 11.3. So as you see, spatial variability in the same leaf changes a lot. Here, this leaf, this is Ficus benjamina, has 33. It looks quite green everywhere. 29.9, 31.7. So it's very simple to stop the measurements. Then you click twice and the instrument is off. So once again I put it on, run, measure, we hold the arm down for a moment, it calibrates, and then now we can take leaf. For example, this is chlorophytum. Let's see. Sorry, append. 8.7, 6.4. So normally I take a few measurements in the same leaf and make an average, because as you see there is some kind of special variation within the same leaf. Thank you very much for watching and see you around.